Hold up. Logarithms come back to this problem that we were trying to solve earlier. 2 to the x is equal to 15. And there is no algebraic way yet of solving for x. So what we need to do is design a function that will answer the question. And the reason I wanted to design a function is if I have f of x is equal to 2 to the x. Ah, look, it's here. How exciting.
I'm losing.
And 2 to the x is a one-to-one function. That means the inverse of it exists. It's someplace out there.
The inverse is...
We'll get to it. I just want to play around with an idea. So, if f of x is equal to 2 to the x, and I know that 2 to the x is a one-to-one function, how do I know that?
Because it's 2 to the x. It's always a one-to-one function.
How do you prove it's a one-to-one function?
That's the horizontal line.
If you can
No,
graph
that's
it,
to prove it has an
what's the
inverse.
absolute proof? So if we do f of a is equal
So 2
to f
of
of
A
b, then 2 to the a is equal to 2 to the b, and then we kind of get into a suck.
Log.
Something raised to a power is equal to the same thing raised to another power. Those powers have to be the same. What's sad is there's another way of proving it, but that's not the best way because that's actually a circular reasoning. And we'll get back to that later. But it is one-to-one. So if f inverse exists, I can solve this equation simply by inverting both sides. So you do f inverse of 2 to the x and f inverse of 15.
What?
You invert to get rid of functions. So this is f inverse. This is f of x. What happens when f inverse runs into f of x on a one-to-one function? You don't remember? It was in the last chapter.
What'd you say?
What happens when f inverse runs into its normal function?
It's been a long weekend. Can you just tell us?
Oh, here, let me write it over here. What's f inverse of f of x? It equals x. When f and f inverse run into each other, they basically go poof and disappear because they're inverse functions. So this side becomes
Something.
X.
Something.
it doesn't become something, it becomes x. And the other side is,
F inverse of 15.
so technically we've
What?
solved for the equation except for one problem. Except for one problem. Shh, guys.
How is F inverse of F of X?
We have to define an inverse function so that we can evaluate it at 15.
How did you get X? How did you get X?
Oh!
Where did 2 go?
F of x is equal to 2x. F inverse exists because it is 1-to-1. So if I take F inverse and I compose it with F of x, this is F of x, what happens to F inverse and F? They basically go poof. They don't cancel per se. And you're left with
X.
x. So that pops down and the other side says F inverse of 15. So technically you solve for x. So let's look at this again, a different way.
Wait, are you like trying to prove something right now?
I'm trying to show you that we can come up with an inverse. It does exist, and if it does exist, we can solve for x. But it doesn't exactly tell me what it's equal to. It's just, it shows me how to get there.
I'm so confused right now.
It's like looking at a map and I tell you how to go from here to Tarboro, but it's totally different when you get in your car. This is the map. Now we're going to show you how to drive.
No, it's not, because I know how to get to Tarboro
Oh,
in my
wow.
car.
Theoretically.
All you gotta do is get on 64.
Theoretically. What if 64 is closed?
What?
Yeah.
What?
What? No, I can't get home.
Okay, I found where 64
So,
it ends in a way. Does it really?
this tells you if you take 2, raise it to a power, your answer is going to be 15. What I need to do is to find what power
I don't have my calculator, so I can't figure that out.
Well, there is nothing to figure out here. What I've posed is a question.
Okay.
And what's cool about questions is once you can pose a question based on numbers or values or other functions, you can come up with brand new functions. So the question I'm saying is, what power do you have to raise 2 to get to your required 15? We're going to call that function log.
Log.
So this function basically says, what power do you raise to? A raise, and then the number you're going to put
X.
is down here,
X.
little 2. So this starts off with, what power do you raise 2 to get to
X.
15?
You raise it to X.
It's a log in natural 10.
Base 10, but we're not going to be talking about them for a little bit. So this log base 2 of 15 is the same thing as f inverse of 15. So this inverse function really is this log base 2 thing. So this is read log base 2 of 15. But in the long language it is, what power do you raise 2 to get to 15? Okay. So if I have this equation, 4 raised to the x is equal to 25. How do I change it into a logarithm? Solved logarithm. It would be x is equal to
Log.
Log
Base of
4.
log base 4. What power do you raise 4 to get to 25? That ain't hard. It's not hard. You just got to get used to this log actually being
Log.
a question. It's actually a question.
Why are you calling it LOG?
Log. Logarithm.
That's how you spell
Short. Log.
Thank you.
Log.
You don't have to say LOG, it's so much longer.
Fine. So there's a big relationship, and this is a starred idea. Relationship between a logarithm and an exponential. Now, for both of these, the most important part is not whether it's an exponential or whether it's a logarithm, because you can always go back and forth between them. The only thing that's in common between both of them is, what is this number called?
What number?
The 2.
Base.
It's called a base, and this number is also called a base. So the most important thing about exponentials and logarithms is recognizing what is the base. So over here, if I write x is equal to log base 2 of y as a logarithmic equation, how do I change it to an exponential equation?
2x.
The base is 2 raised to
X.
the x power is equal to
Y.
y. Oh my gosh. Half the problem, actually I would say more than half of the problems in this chapter can be solved that way. Just fluctuating from an exponential to a logarithm or vice versa. What if we started off with e to the x is equal to 17? E to the x is equal to 17. How would I change that into a logarithm?
Log to the base of e.
Log to the base of e.
But it
So
would be just
17.
log, right? You could just put log.
No, you
L
cannot.
times
log to the base of e of
17
What is
17.
ln?
equals x.
Don't talk about that yet. Is equal to x.
I remember us doing ln.
Yeah, we're getting there.
Okay.
We're getting there.
Slowly but surely.
Slow.
You
Don't go
just
too
take
fast
your
with this
time.
stuff.
Just take your time. I don't care.
If I have log a base 8 of 2x minus 3 is equal to y squared, how do I change it to an exponential?
Don't do it. Wait.
It would
Let me
be-
Let me do. 8.
8 is the base,
8 to the y squared.
which is weird to begin with.
That's cute.
Equals 2x minus 3.
Ta-da. So it's not really that hard. So just with letters, this is how it works out. No numbers. This just means they're interchangeable. This is just the interchangeable feature of logarithms and exponentials. And again, will solve about half of this whole chapter. All right, the other thing that might solve this chapter, if you have log base 5 of 5 to the x. What do you think that's equal to?
1.
Huh? Log says, what power do you raise this base to get to this number?
It would be 1.
No.
No. X.
What power do you have to raise 5 to get to 5 to the x?
X. Oh,
X. What property is that?
It's the identity property. Wow, I'm right?
No.
Oh.
Starts with the right letter. I'll give you that.
That's what I thought I was right.
If I have 7 raised to the log base 7 of x minus 1, what's that equal to?
X minus 1.
X minus 1. What property?
Identity.
Stop it. It's right there. They're inverse functions. They have the same base, and they're basically going poof. So you're just left with what's left over. So here, log base 5 and 5 to the x, the bases go away, and you're just left with what's left.
Yep.
Inverse property. So this is that f of f inverse of x is equal to
Too much.
x.
I'm so tired.
Oh. Should have slept in this morning. Or not.
Oh my god.
All right, some other little baby properties. What is log base b of b?
B.
1.
1. What power do you raise b to get to b? B to the first
1.
power. All right. What's log base b of 1?
0.
0. What power do you raise b to get to 1? B to the 0.
F the 0.
B to the 0 power. Can a logarithm be equal to 0?
No.
No, I'm sorry. Can the logarithm take 0 and give you an answer?
No.
Why not?
Because nothing
This is
you can
zero.
raise to you can't raise anything to a power equal to 0.
Right. If I tried to write this,
That's unreal.
some number, let's say it's equal to some number, this turns into b raised to the a power is equal to 0. Now, if you remember the graphs of the exponential functions, what's b to the a look like? If a is
It
variant.
goes through 1, but it never touches the 1.
Kind of goes up like this, right? And as it goes this direction, how close does it get to the x-axis?
Very.
Extremely.
But does it ever touch it?
No.
No, so this is never going to be true.
So eventually we want to run out of numbers.
Because there's an infinite number of them.
That's not cool.
So you can go 0.00000 and then just keep putting a 0 in front. 0.0, 0.00, 0.000, and just keep pushing that number further and further out.
Are you going to use scientific notation?
What's that?
Are you going to use scientific
Ugh,
notation? What?
why would I want to?
Because it's better than writing like 29 zeros.
Boring. Oh, graphing.
No.
No.
We'll say that from mom.
Why are we
Nah.
doing this?
This is
Who
easy.
came up with graphing logarithms?
If f of x is equal to 2 to the x. Well, you know how to graph this one, right?
No.
I hope. So let's see. Draw a decent graph.
I'll put it in a calculator for you.
What does 2 to the x look like?
Oh.
Calculators make it look funny.
Well,
What is it,
You
Hug?
make it look funny.
it's like the bread. We don't skip here.
It would be 2.
This is 0, 1.
It goes through 0, 1.
Goes to
1, 2.
I don't want it to go. What does it do as it goes to the left?
It goes.
It goes down.
It goes down, approaches the x-axis. What is the x-axis called here?
The x asymptote.
A horizontal asymptote.
Oh.
Close enough. Close enough. Horizontal asymptote.
Asymptote.
Asymptote, fine. As it goes through this point, it'll shoot up. So you get that as the graph of 2 to the x. Now, we also learned last chapter how to graph an inverse. How do you graph an inverse?
You flip it.
Flip
You
it.
take all the coordinates you can think of and flip it. This one is like negative 8.1 if you want to think of it. So if this is negative 8.1, what would it be on this side?
8, negative 1.
What is it?
8, negative 1. That I got
0.1 negative 8.
That's what I got.
Yeah. So 0.1 negative 8 would be down here someplace.
Yeah.
0, 1 would become 1, 0. And then something over here would just be like
4, 5.
4, 7 or something like that. So you get 7, 4,
Yeah.
something like that over there. So this graph,
That's the point.
what happens as it gets closer over here? What happens as I push the graph in that direction?
It never touches the line.
It never touches the y-axis for the same reason this doesn't touch the
It's a vertical
x-axis.
asymptote.
It's a vertical asymptote.
Oh my gosh.
What?
That's awesome.
What'd she say?
That's awesome.
Oh. Vertical asymptote is the y-axis. So where exponentials have horizontal asymptotes, logarithms are going to have vertical asymptotes. When I ask you one of these questions, I'm going to give you options, and they're going to be looking like the blue one and the green one, but you have to pick the correct one. Green one is always an exponential because it's hugging the x-axis. The blue one is a logarithm because it's hugging a vertical line or a y-axis. So you got to keep those two separate so you can draw these graphs decently.
Wait.
I'm going to
So
randomize
we
it.
have to have colors.
Exponential functions always have horizontal asymptotes. Exponential graphs have horizontal asymptotes. Logarithm functions, let me draw it in here first. This is f inverse x log, equals log base 2 of x. Logarithmic functions have vertical asymptotes
Log 2x.
on one side. Now, notice where exponential functions are constantly growing and they grow really fast. Logarithmic functions grow really very, very slow. And they're actually used for a lot of things that get too big to begin with. Richter scale.
Oh, good.
You know, Richter scale is supposed to be how much energy is produced by an earthquake, but it produces so much energy, the number is absolutely huge. So they use logarithms to make the Richter scale number between 1 and
Like 5 or
9, I think it is. If we have a 9 Richter scale earthquake, we're all dead.
Oh, I thought that. Oh, I was thinking hurricanes. It's 1 and 5. It's 1.
Hurricane's the same idea. They use a weird formula, though. I've never seen it. All right, so logarithm base logarithm, log base b of x graphs. We're only going to concentrate on bases bigger than 1. Bases between 0 and 1, they're going to do something weird.
Yeah.
We'll talk about that in a second. So if you're bigger than 1, your basic logarithm graph is going to look like this. It's going to go through the point 1, 0 instead of 0, 1. It's going to have a y-axis vertical asymptote. And after it passes this point, it's going to grow very slowly, almost like a square root function.
Are we going to need colors for this one?
If you want. It helps sometimes. What is the domain of this graph?
Colorful.
Give me a number.
The domain is y is
Parentheses, 0.
or x is greater than 0.
So I put
0 to
parentheses,
0.
0 to infinity. It can never ever touch the y-axis and it goes off to infinity.
Infinity.
Range is
Beyond.
negative
All
infinity
reals.
to positive infinity.
And the range is negative infinity to
That means everything.
everything,
All
all real
real.
numbers.
All
Remember,
everything.
exponentials were all real numbers for the domain, and 0 to infinity for its range, and the domain and range just flip.
Yep.
Alright. So now we should be able to graph other weird things.
No.
The other what?
Weird things.
No.
Nope.
What time is it?
It's not time not.
This time.
It's not even close.
Yes, ma'am.
It's only 2 o'clock.
Really?
Suckers, yeah.
Only 30 more minutes. We can do it, guys.
Try that.
I was thinking of that.
That's why they're like,
This is such a hard class.
it is.
It is when it's this early.
It's hard when you don't understand
And I've been up for about an hour.
It's easy when you're a genius like me. Just kidding.
Genius.
Bridget, figure this out.
Well, let me write it down first, Sam and Joe.
You're thinking, me and Brandy were thinking the same thing when we heard what time it was.
What's the 4 do?
Yeah.
Down 4.
Uh-huh.
What's the 3 do?
Left.
Left 3. Now the base is bigger than 1, so it should have that general shape over there, and it's a logarithm. All right, so you start off. What? You yawned through that question. The base is bigger than 1, so it generally has this picture.
Okay.
Okay.
Gotcha.
Wow. All right. So left 3, down 4. 1, 2, 3. 1, 2, 3, 4. Highly suggest you get those reference axes in there. Otherwise, things look really weird.
It's gonna go down. It's gonna be down to 3. Why are we doing that?
Because I need to shift it the right way.
What?
Left 3. So.
Everything has to be shifted left 3 and down 4. The
Okay.
entire
See,
graph.
I was thinking that it would be
I know.
2. It's gonna be 2.
So this is where the origin used to be. Where's the point of this graph going to go through? Here's the origin. Where's the graph normally go through?
It goes through 1, 0.
Goes 1 to the right, whatever it is.
It's
So you
gonna
start
be
here
2,
at
4.
-3, -4. You move 1 to the right, that becomes
-2 to -4.
-2, -4. So that's the common point that we're going to go through. Remember, sketching, you only plot 1 point. All right, what's the other feature of that graph that's nice?
It never touches the Y.
So we have a vertical asymptote. Is it high or low?
It's low.
It's low. So this part of it's going to go down, and the other part is going to go
To the right.
slightly up like a square root function. So you get that graph. Domain.
Why?
Why not?
Domain.
What is the
Wait,
domain?
Domain is
-3
-3 to
-3 to infinity. Not including the -3. Range.
All
Negative
reals.
infinity to positive.
Or all reals if you want to say it that way. Yay! So what happens if I take that base and make it, well, smaller than 1?
You'd flip it, wouldn't it?
Well, like log of a half. Log base a half.
You'd flip it.
That would look weird.
It'll look weird, yeah. Let's just look at that.
What?
I'm curious how to. I know what it's going to do. I have to prove it though.
I mean, I can put it on the calculator.
Yeah, you can put it in your calculator. Is it going to flip over the y-axis or the x-axis?
It's not flipping.
Why?
It's got to be flipping. It's got to be doing something weird.
It should
Um,
be stretches.
It doesn't have to flip and
It flips.
Yes.
It flips.
All you gotta do is graph it exponentially and then just flip the points.
We could do that. We could do that.
Why don't we just do that? Poof.
If I have x is equal to 1,
I don't know.
Yes.
if x is equal to 1, what's log base 1/2
Zero.
of 1? It's 0. So it goes through our famous point 1, 0. That's good.
It's gonna be straight.
Let's go between 1 and 0. A half.
How do you know it's 0?
What power do you raise 1/2 to get to 1?
0.
The only thing that you could raise a power to get to 1 is 0. Anything raised to the 0 power is equal to 1.
Okay.
Okay. So, what power do you have to raise 1/2 to get to a half?
1.
1. What power do you have to raise 1/4 to get to, I'm sorry, 1/2 to get to a fourth?
2.
2. What power do you have to raise 1/8 to get to, 1/2 to get to 1/8?
3.
3 and so forth and so on.
It's a straight line.
Nobody go.
Ugh, to plot this though. Let's go the other direction.
I don't want to.
2. What power do you have to raise 1/2 to get to 2?
1/2.
No.
1/4.
What is it? No, not 1/4. What power do you have to raise 1?
-1.
-1.
I knew that.
What power do you have to raise 1/2 to get to positive 4?
-2.
-2. 8?
-3.
-3. All right, we can graph this. Okay.
Why don't we just graph
Now,
those last?
this is a graph, not a sketch. Be clear about that. So 1, 0 is here. 1/2 1 is here. 1/4 2 is here. 1/8 3 is up here someplace.
You just gotta think about it as backwards.
Yeah, it's backwards completely. So it's going there. And then when you hit 2, where do you go? -1, so you're down here someplace. 3, I'm sorry, 4, further out. -2, so you're a little bit lower. 3, or I'm sorry, 8, way over here. -3, you're down here. So you get a graph that looks like that, which is flipped over
X.
the x-axis. So by making the power the base between 0 and 1, this
I
flips over
thought
the
that it was.
x-axis.
So does this have different rules than normal translations?
No, it's just
No,
you
no,
flip
it's just what's happening to the behavior. Because if you made the base in an exponential 1/2, what does it flip over? The y-axis. No, it flips over the y-axis. So here we would expect it to flip over the x-axis because they're inverse functions.
Oh God.
Wait a minute. If this is flipping over the x-axis,
Ooh.
ooh, here's
2
an
would
idea.
flip over the y.
What normally makes things flip over the x-axis?
Negatives.
Changing all the positive y's into.
Negative y.
So this thing must be the same as log base 2 of x, but what's in front?
Negative.
So somehow, log base 1/2 of x is the same thing as negative log base 2 of x.
Yep. That's why I thought that was.
But why?
But why?
Why not?
But that's what you have to ask it now. Why the heck is that working? Why are you wiggling your finger?
Because I'm thinking of the
Because she's
fractions.
Sam.
No, I'm thinking of the fractions where you just flip them upside down.
And what happens when you flip them upside down?
Quiz time.
What changes? No, it's not.
The y's. Well, not really the y's.
Exponential is fine. Get rid of that.
Wait, I missed it.
So, let's graph this.
Let's not say we did.
What do we
G
have?
of x. I'm sorry, sketch.
Let's.
Let's
Why
sketch
would
graph.
we want to sketch when we can graph?
Because I want you to be able to
Wait.
make shapes rather than
Wait,
precision.
is it graph or sketch?
It's sketch.
2
Erase graph,
plus
please.
log base 2/3 of x plus 1. I can't get really too hard with these.
Yes, you can.
No, you can't.
Yeah.
Nearly impossible to get nasty with these.
Make your nose cheap.
What does this graph do?
It goes to the left one.
It goes to the left one,
It goes up 2.
and it goes up 2. What else does this graph do? What else does this graph do?
It flips
Over,
x.
because this is less than 1,
Stop.
it flips over the x.
There you go. You're
All right.
a genius.
So where do I plot my point?
Well, you usually plot it at 0, 1.
That would be here.
I'm sorry, 1, 0.
That would be here.
So now you would plot it at 2, 0, 2.
0, 2. Be right here.
And then it would flip over the x, so it would go like this.
It would come down the vertical, hit this point, and slowly crawl off its own way over there. But it does have this vertical asymptote, so you have to be careful. Logarithms have vertical asymptotes.
Mary Catherine's a genius.
Mary Catherine is a genius, and we'll see that one of these days.
Mary Catherine is a genius, and you
And
will
we'll-
see it today.
And we'll see that one of these days. Ah.
Miss Ellen, thank you.
Dun, dun. Boring, boring. Did that. Eh. I'll let you figure that out on your own.
No.
Ah.
Stop. No, don't do that.
Why not?
Because I'm lazy.
Next section.
What?
Yeah, we're done with it.
Next
Logarithm.
section,
Actually, there's 2 more little small pieces.
Okay, this over next section is have quiz.
Wait, new sheet of paper or same sheet of paper?
Now, this is the same section. I'm sorry. This is still for
3, 2.
3-2.
We aren't in section 4.
Different textbook.
Yeah, I have a chapter 4.
Common log. If you have log base 10 of x, we are just going to write that log of x. Kind of like square roots, they have an index of 2, but we don't write it. We just kind of ignore it and assume that it's there. So when you see log by itself, it's base
Log
10, which is the same thing as on your calculator. Log on your calculator is log base 10.
How do you change it?
You don't. You have to use a formula.
The x, log base x to some. That's when
What?
I know where you're going. If you have a natural logarithm,
Well, we got to slow it on down here a little bit.
I haven't gone in over really anything, so.
Yeah, well, I'm trying to
Yes,
write
you
it.
have.
No.
Yeah.
I'm still-
See, we had a math teacher one time that let us write, and she didn't say anything because she figures that we can't write and hear at the same time.
That's really
No,
sad.
Miss P, we never had her.
If you have
That's
log
what you should do.
base e of x, this one's important.
Oh, yeah.
Most people understand log has base 10, we have 10 fingers, all that fun stuff. E being a new weird number, the
ln.
natural number, this is called the natural log.
So it's going to be ln.
This is the ln one. So if
That's
you see
what I was
ln,
thinking earlier.
if you see ln, you have to think base e. If you see log by itself, you have to think base 10. So if I write something like log of 22 is equal to y, how do I change it to an exponential?
10 to the y power equals 22.
The base is 10, the power is y, and it's equal to
22.
22. If you see 7 equals ln of x minus 1, how do I change it to an exponential?
E to the 7
E to the
minus 1.
Base is e, power is 7, and it's equal to?
X minus 1.
When you select what's going to go with the power, always choose opposite the equal sign. Don't choose same side as the equal sign. You always want to go opposite it. So it's e to the 7th and 10 to the y. It's always opposite the equal sign.
Yep.
All right, so that's natural and common logarithms. How exciting.
Quiz time.
Say I can't even think straight.
So, silly little questions.
Three.
What is it?
3.
3.
Why not do this?
Yep, this is easy.
Oh,
Negative,
wait.
negative,
Negative 6.
-5.
Oh, that's one.
Negative. As long as you got the negative in there, I was actually kind of happy with that.
negative
What?
Yeah.
-2. What power do you raise 1/3 to get to 9? It's 3
Squared.
squared, but it's in the bottom. You're so excited.
It's from to the
Oh, jeez.
second power.
3.
Three.
Cute.
You're a genius today.
3.
Ah, you lost it.
Why?
Because she came up with the answer first.
Well, I thought it was 2.
I said 3.
I said 3 first, girlfriend.
I said cute. It's kind of
Cube is not the answer.
What? Cute.
It's 3.
is 2.
No, it's 3.
Cube
Not
is
cube.
3.
No, cube is x cubed.
This is
Um,
10 to the 3.
yeah.
Point one.
It's
Point
1.1.
Wait, is that times 1 or?
E raised to the point 1.
I thought it was times.
E raised to the point. Notice there's this space here.
Yeah, I know.
It looks like times.
If it was E times 1, I'd write this.